Hey guys, welcome to Python. So in this video, we are going to not do Python, actually. So we're going to get introduced to the Linux environment and the command line. They're Python and Bash, or the command line, or Shell, depending on kind of all different names for the same thing. They're very interchanged. So the command line / shell / bash are ways to manage your files, to navigate your system, your directories and things like that. Python is kind of the engine that does the work. You can write scripts in bash and things like that, but Python is much more suitable for doing the work. So with all that being said, let's kind of figure it out by digging into it. Okay, so actually, let's go back to kind of show you where I'm at. So here is the learning pathways. You're missing the one on the far right just because it's off my screen right now, but there's one more, a purple one over there. So, all right, so we're going to do this one. Right, the command line introduction. As you can see here, it opens my environment. Okay, and so since this is command line, so this launcher here, you can launch Python, a notebook, which is kind of like a savable document. You have the console, which will just run your scripts whenever you write them, but it won't save anything. And then we have these other tools down here. And so you could write a text file if you want to write, a nice letter to your mother and send it to her. No, you can actually write Python scripts in this as well. But we'll save that for another day. But we're going to use the terminal. So the terminal, this is bash, shell, command line, like I said, multiple names. And so the first thing we're going to do is let's get a FASTA file. So FASTA files are files that are ATGCs of a piece of DNA. So the nucleotides sequence of a piece of DNA. So wget is a command that allows you to pull or download a file from a web address. So you don't have to go to the website itself, you just have to type this wget command. And then we say golden path.ci3, oops, not G3, big zips ci3.fa.gz. Let's go gz. Okay, so let's talk about this quick. So obviously this is just a file hosted at a USCS, so USC San Diego, I believe. There's a US Santa Cruz, I can't remember. Anyways, hold on. I think Santa Cruz, right? No. Wait. .org. Universal Ship Collection Society. USCS.edu. SOE.edu. That's right. Santa Cruz. Okay. Yeah, so UC Santa Cruz has this big genome browser. And so this must be their kind of back end where you can download the files. So, anyways, UC Santa Cruz. Alright, so I have a typo. So if you one cheat with bash and Python and R, instead of having to retype everything, if you just hit the up arrow, it will bring your last command up. It won't fix it, but it'll allow you to be able to edit it University of California, Santa Cruz. There we go. That's why I was so confused by what USCS stood for. All right, so we downloaded our file. All right, next things. What we can do is there's a command called ls, and what ls does is it lists all the files and folders in your current directory. So we are just in our home directory, so as you can see we have, let's see if I can make this bigger. I want to make it perfect. Okay. So as you can see we have Anaconda 3, which is just a Python suite that has a bunch of different like biology packages and analysis packages built into it already. Actually, I'm gonna move this over to you so you get a little more room. We have desktop documents download, so this is just kind of our normal like file directory, right? We have music, pictures, blah 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 blah, all this other stuff. But you'll also notice that we have ci3fa.gz. So this is the file here that we just downloaded. And a GZ file is a zipped file. So unlike in Windows, I don't know much about Macs. Like for being a computer guy, I know like nothing about Macs. But for Windows, you usually have zip files. That's kind of it, right? But for Linux environments, you have GZ files, you have tarballs, you have zip files, a bunch of different ways to compress, and you can actually do like .tar.gz, so it's like double compressed to make these files very small. But there are different commands, so we're going to do gunzip, which is unzip a G file, so gunzip ci, and so a shortcut with bash generally bash is if you type the first couple letters and that's the only file in the directory, you can hit tab and it will fill it out the rest of the way. But for example, if I say I say the letter D, and so we have desktop downloads and documents. If I hit tab, nothing it happens. It like lists everything. So if it's the only file you know in that directory that you're looking for, you can hit tab and all of them. So now, if we hit ls, after we've run the gunzip command right here, you can see that ci3.fa, it's lost the GZ, so it's uncompressed. So it's much bigger than it was before. And it's ready to be looked at. But let's look at some other Linux commands. So first, let's look at our, we can use uname to see what sort of operating system we're in. So if we type uname in our virtual environment, we have Linux, that's what we're working in. If we do uname.a, and this is kind of all the Linux stuff. So we have the different, we're in Ubuntu, we have when it was builds November 23, etc. So it's like very specific information that you probably won't use. The only time you ever will use this is if, I actually used this quite recently. So my two grad students were trying to do an analysis with this package to look at pathways that RNA-seq. Anyways, it was an RNA-seq type package. So we couldn't get it to work, and I tried like hours trying to get it to work to like help them troubleshoot. Eventually, I went to the writer of the package, the person that wrote the software, and I said, I'm having these issues. I can't figure it out. I've tried hours. And he said, okay, send me the files you're using and send me your environment, which means this information, right? So it's like, because sometimes if you run it on Ubuntu 22 versus Ubuntu 18, you're gonna have different weird things happen in the background. So if you're troubleshooting with like a developer, they'll ask for this information. So just so you know. Okay, so let's look at the ls argument again. So we have ls, which is just normal that we used before, just lists what's in the folder. If you ls.a which is all, it has all these dot files. So these are normally hidden files that are in that folder, but if they're hidden, it means you shouldn't mess around in them really. Sometimes you're asked to, but they hide them for a reason. So if we do ls.l, which is to list everything, if we do ls.al, so all and list them, it lists the hidden ones and the non-hidden ones. If we do man ls, it gives us kind of the manual for ls, right? So it says this is all the things to do that you can do with the ls command. So I'm gonna hit Q to quit, but if you want to like really dig into the ls command, you can. If you want to dig more into it, so like man, hold on, let's do man ls again. I have to pull up. What's a good one to pull out? R. Capital R for recursive. So if I do man R for recursive. Oops. Maybe I have to get rid of that. Let's try this again. Let's see. Oh, we need the command name, not the added. Okay, I see. Right. I messed up. All right. So if what's a command? ls. So if we say man ls, so that was our command, not the arguments like I was just trying to add. What? What's a different command name? Let's do name. There we go. No brackets in it. All right, so if you want to know what a command does, you just type man and then the name of the command. So ls, here's the manual for the ls command. Just hit Q to get out. Man, we'll talk about this one in a minute. CD for like, what? Oh, there's no manual for CD, interesting. Which is current directory. Anyways, all right, that's kind of bumbled away. I don't use it very much. So the manual thing, it's there, but you might not ever use it. PWD, so that is print working directory. So it's kind of like set WD for R if you use R, which is set your working directory. It's just where you are currently working out of. So right now we are out of home/student. If you want to make a directory, so essentially make a file or a folder in your current directory. What you can do is mkdir, make directory, and then we'll call it test. Not trust, test. Now if I hit ls, you can see that there is a blue, in this case, which is Alright, so if you hit ls, you'll notice that there is a test folder here. I'm going to have to zoom way down so you can see. Alright, so now there's a test folder here that we made the directory for. Or you could do a different example. You could do, in this case, mkdir, and we'll say genomes, because we'll be doing genomic stuff. So if we hit ls again, and I zoom it up so you can C, should have genomes, which is right here. So, now, let's do this copy function. Okay, so copying is done with the CP function. It stands for copy. And when you copy a file, you can change the name of it. So the first file you have, and I'm going to do this cheat with a tab, right? So I type CI tab, and it fills in the only CI one, which is ci3.fa. But I want to copy it and rename it at the same time. So I'm going to type C squirt.fa. And so that is the name of the organism. So if you are interested, C squirt, this is the dude that we have a genome of, right? This little sea cucumber type looking thing. All right, C squirt. And so now if I hit ls again and I go way down, you can see that we have our original CI3 file and we've copied one that has csquirt.fa as the file. And so you can actually also move files as well, right? So let's see, hold on. So let's try this. So this, when we use this move function, so here we did copy ci3 to c squirt.fa, right? So we had ci3fa and then we created c squirt. You can also do move, so we moved ci3fa, and instead of making a copy, what it does is it just renames it. So we're saying move the information from ci3fa to a file called sionagenome.fa, and you can see that there is no more ci3fa, it just renamed it. So it's kind of a funky way to say rename function in command line. All right, so we can change directories, and that's done with cd. So we can do cd genomes, that directory that we just made. If we do ls, you can see that nothing comes up because we didn't put anything in there. We could do, to go back up out of that one file or folder that you made, you do cd ... and see now we're back into our normal that we were working in directory, our students directory. If you want to view the contents of a file, we can hit cat and we'll do the Siona one. How big is this genome? We shall see. This might take a minute. This is a pretty fast virtual machine. That is essentially what Praxis provides us, because it might not go this fast on your home computer. I picked the wrong file to use. I made a terrible mistake. Let's see. Hey, there we go. Well, that wasn't that bad. All right. Good on you, C squirt. So we've just seen the entire genome of the C squirt. You can also do less. Let's try it again with just less. All right, so see, it just provides, it prints it out like the first so many lines, and then you can kind of just browse through it by hitting enter or scrolling down. How do I escape out of this? Q. Q escapes you out of that. You do head. This is similar to R if you take R, so this just gives you the first like 10 lines or whatever of it. Tail, which just gives you the last 10 lines of the file that you're interested in. If you want to remove a file or delete a file, you do RM, and let's see, what did we have? We'll remove this Siona one because we still have the C-squirt one. Why isn't it letting me? Oh, it's because I put that dash in. There we go. Remove Siona. So now you can see that that is gone, and we just have. Oops, move down. We just have the C-squirt one still somewhere. There it is, which is just a copy of the same thing. The other thing too is if you want to remove a folder, what you do is you do RM and you do -R, and so we'll do genomes. Let's get rid of our genomes folder. So actually, let's copy. I'm going off script here. Let's copy the C-squirt, and we're going to copy it to genomes, and then we're going to do C-squirt. Alright, so now if we go to CD genomes, you should see that we have not in the genomes file, we have the C-squirt. So let's back out, so cd ... And so genomes is a folder that has a file within it, right? Which is our copied C-squirt genome. So if you want to remove a folder with everything inside it, what you do is you do RM-R, which stands for recursive. So it means remove the folder and everything that's inside it. And then you type the name. So we'll say genomes. And so now our genomes folder, as well as that copy of the C-squirt genome, is both deleted. Okay, let's move on to some other. There we go. So df-h. This shows the amount, like our system data, like how much memory and all that stuff that you have available. If you're this, you might be like, who cares? If you get into this and you start working with genomes, and for instance, I'm doing a collaborator with Dr. Becky Giorno, and she is doing some metagenomic stuff. So I decided to try to run it on my laptop or on my desktop, and it worked fine. But the reference genomes, the compilation of all these genomes that you compare to kind of identify who is in the sample, I think it was like 700 gigabytes. It was almost a terabyte. So Space Management becomes an issue when it's like I had to put on a SSD that was 1 terabyte. And I was like, yeah, this will be fine. And then it got to the point where I was like, I might run out of space here. So when you work with genomes, it's a lot of information, a lot of data. So this might be something to keep in mind. All right, so free H is your memory, which is also important for running these things. So you can see we have about 32 gigs of memory, which is a lot. That's I think that's what my desktop has. My desktop's pretty loaded. So we can do some stuff on here, which is good. The top displays the top running processes on your what's going on right now. So it's kind of like Task Manager in Windows. It's like something else in Macs. I'm sorry, Mac people. You can see that there's just processes running. Jupyter, I saw it there. Things are moving around. I don't know. So there it is, Jupyter Lab, student. And then it moves somewhere else. Anyways, so if you're, it's more for on your desktop type thing. And then you just press Q to quit. And last thing we're going to do is we're going to type exit. And we're out. So, man, these are running a lot longer than I thought. All right. Maybe I need to tone down the rhetoric, right? 28 minutes. All right. So that is your introduction to the terminal. It's really important to know. There's not a lot to the terminal. Like, that was generally it. Like, your masters at terminal out. You can write bash scripts and things like that, and we might get a little into that, but for the most part, it's copying files and moving files to the right directory, so when you run a Python script, it's in the right spot. Downloading data, the wget function, is really important. Unzipping that data, although a lot of Python in R packages will automatically unzip the data for you, not all of them do. So unzipping the file to a not GZ or tar or zip file is important. It's just kind of manipulating all your ducks in a row before you end up doing your analysis. And so to keep this short, that is it. 30 minutes. Here we go. I hope to catch you in the next video. If you're watching on YouTube, hit like, hit subscribe, and we will continue on our Python journey, and I will see you in the next one.